for joining us for another Water Issues Seminar. It's a pleasure to introduce Jim Berg from the DNR as our speaker today. Jim is one of these guys who has an impressive resume, even in abbreviated form. He has been around the block, as we say. He has worked as a hydrogeologist at the Minnesota Department of Natural Resources for 26 years now. I bet that's starting to sound like a bit of a stretch, Jim. Kind of like me.
It's hard to believe. Yeah, it's a big
It's
number.
hard to believe, but true. And he says prior to coming to the DNR, he worked with environmental consulting companies in the Twin Cities area and with Champlain Petroleum Incorporated and in Denver, Colorado as a geologist. He studied hydrology, hydrogeology, and glacial geology at the Colorado School of Mines and at the University of Minnesota. And before that, he earned an MS in geology at the University of Kansas. And before that, way back when, a Bachelor in Arts in Geology from Carleton College in Minnesota. Jim, thanks for being with us. Looking forward to your talk on groundwater provinces. I have a great deal to learn from your talk because I know nothing about the provinces of groundwater. So looking forward to it. Take it away.
Thank you very much. Yeah, nice to be here this morning. And really, parts of this talk will take me back to the early part of my career at DNR, which is kind of fun to be rattling around in those spaces after so long. I'm showing the show in this PowerPoint mode because of the multiple screen issue. So I hope that's not too distracting. You should have a pretty big image of the slide anyway, and
yeah, it's coming through just fine, Jim. So yeah,
and you
no
should be able to
worries.
see my cursor. Okay, great. So this is a map I made a long time ago. Speaking of a long career, about 20 years ago, and it's been useful for me for presentation and explaining big picture things, and apparently it's been useful to others as well, as I'll get into at the end of the show. In a nutshell, we live in a state with abundant water resources, but those of us who work in groundwater know that it's not evenly distributed across the state. So if you don't understand the reasons behind this apparent paradox, it becomes kind of a confusing thing, hard to explain to non-geologists. So the purpose of this map is to get over that apparent paradox. My show today is, I'm going to start off with where this idea came from for me way back when, what sort of pushed me to make this map. I'm going to drag you through the geology basics for, as Mark said, for people who don't know really anything about it. So I'm going to assume that you don't know anything about it. I'm going to highlight what has changed in this 2021 version versus the 2001 version. And then I guess because I've worked in County Geologic Atlas program for 20 years, I have to tie that in somehow. So I'm going to make some CGA comparisons, and then we'll look at applications that mostly what I've found by looking on the web, seeing how people have used it. So way back at the beginning of my DNR career, I was involved in a project to try to find aquifers in southwestern Minnesota, and that whole effort was funded by the legislature, was inspired by this project, this proposed Lewis and Clark water system, bringing Missouri River water to Sioux Falls in southwestern Minnesota. And the Minnesota Waterwell Association got the legislature to appropriate a whopping sum of $50,000 to be matched by local participants to drill exploratory holes in southwestern Minnesota. I'm guessing their hope was that Maybe we would find something big, and then maybe this wouldn't happen because it's concerning to them. If you have rural water coming in from out of state, then people drill fewer wells. So I volunteered for this project, and we drilled holes where all these yellow triangles are back in 96 and 97. And, the short story is that we didn't find a lot in any of these areas, with the exception of this area north of Marshall. There was a pretty good aquifer, but certainly not enough aquifers found to derail the Lewis and Clark regional water system. But it got my head in a place where it just became so clear that finding good aquifers in this part of the world was very difficult. And do other people understand this? And I was giving presentations to local groups and professional groups, and I needed a slide to show this uneven distribution of potential groundwater resources. So the idea for this groundwater province map was hatched at that point. And then ultimately, this is where the system is now. There is Missouri River water going to Laverne and Worthington. It's built out that far. But it took a very long time. These projects are very long-term projects, take a lot of planning. And oh, by the way, there is another proposal to bring Missouri River water over to Fargo. The pipeline would go to the Cheyenne River, dump water into the river, and then Fargo would pick it up. Only a stone's throw away from Minnesota at that point. So another part of the state where water shortages are a real concern. So next I'm going to get into the geology basics. What are the different components of the province map, and why do they look the way they look? So I'm going to explain the bedrock distribution, and then the glacial sediment distribution, and the map is a combination of those two parts of the geology. Going way back 1.1 billion years ago, there was the continent, such as it was at the time, tried to split apart, and this rift valley formed across the upper Midwest, creating a big hole that lava oozed out of. That's the volcanic rocks at this green bit. And then in a later phase, that hole began to fill with sandstone. So that's this sort of tan colored stuff, creating the Hinkley sandstone. So that's part of the bedrock story. Much farther on in geologic time, 500 to 450 million years ago, there were sedimentary basins in the mid-continent area, and we're interested in this particular basin, the Hollandale embayment, where a lot of the rocks that we're familiar with, sedimentary rocks that you can see in the Twin Cities area, Jordan, Prairie du Chien, Mount Simon were deposited. So we've got an area of Paleozoic sedimentary rocks here, and then a little offshoot of Mesoproterozoic Hinkley sandstone rocks heading up towards the eastern part of the state. This is kind of a summary of those two types of rocks together. Again, the Paleozoic sedimentary rocks down here, and then this sandstone represents the extent of the Hinkley sandstone up in Pine County. So this is the sort of footprint we see for good porous sedimentary rocks that make good aquifers. And then if we flash back to the province map, that footprint follows this outline, creating parts of provinces 1, 2, and 3. And now you can hear my dog in the back there. So moving on to the glacial sediments, in order to understand the distribution of glacial materials, you really have to look again back at the bedrock. And this is a very generalized representation of what the bedrock looks like in Canada and Minnesota. But it's the Canada part that's really interesting. Big difference between this part of Canada and this part of Canada. There are, as I'll show in the next slide, there were glacial advances out of the Northeast from the Rainy and Superior provinces, and then there are glacial advances out of the Northwest, the Winnipeg and Riding Mountain, I'm sorry, provenances, not provinces, provenance. And that set up a situation where the derived sediments from glaciers that moved to these areas had significant compositional differences. The glaciers that came out of this Northeast area eroded crystalline bedrocks, bedrock that contained quartz and other sand-forming materials, whereas the glaciers that came out of the Northwest were dragging over carbonate rocks and shale that didn't contain quartz and forming durable sand that was then subsequently deposited in the till and outwash layers. And then here's a different view of that situation. Again, the history of Minnesota is a sort of complicated dance of alternating advances out of the Northeast and advances out of the Northwest, creating very different kinds of glacial sediment. And those different types are summarized in this table up here with advances out of the Northwest, the Riding Mountain and Winnipeg provenances having textures consisting of loamy to clay till and loamy to clay till in the Winnipeg versus advances out of the Northeast with textures of the glacial till being just flat out sandy in some cases, or at least sandy loam in other situations. Another picture of those glacial advances going from early Wisconsin through Wisconsin or later Wisconsin. The glacial history of these layers is still a little bit up in the air exactly what was happening in the early stages, but we have a pretty good idea of what happened during these phases with a lot of Wadena lobe deposits coming out of the Northeast, again with that sandier sediment. There are at least 3 advances of the Wadena lobe building up layers of what is now called the Hewitt Formation, and then forming a pretty prominent topographic feature called the Alexandria Moraine over in the western part of the state. And then also numerous advances, or not numerous, several advances, at least 4 of the Superior lobe out of the Northeast, again transporting that sandier sediment, and then followed finally by an advance of the Des Moines lobe out of the Northwest with the clayer finer grain sediments. So again, these have the aquifers formed by these advances have good aquifer properties. The aquifers formed by this advance and previous advances out of the Northwest, thin discontinuous sands and till that's much finer grain than the till in the Superior lobe and Wadena lobe deposits. So here, if you look at the topographic map of Minnesota, you can see the prominent outline of the Alexandria Moraine, and then some hints of the St. Croix Moraine down in the southern part. again, that translates to the boundary of one of the boundaries between the provinces, the 4 and 5 boundary, the Alexandria Moraine and the St. Croix Moraine. And then the last component that goes into this mix of geologic conditions for the province map is the thickness considerations. You can see from the statewide thickness of glacial drift that it's fairly thin up in northeastern Minnesota, and the drift is pretty thin to absent, or really thin to absent in both this area and this area, and then some scattered thin areas down here corresponding to high Sioux quartzite areas in the Jeffers petroglyph location, and then in the Pipestone location, again, pretty high Sioux quartzite, thin glacial sediment. Putting this all together in sort of a GIS way of thinking, we're combining this layer with this layer to come up with these 6 unique combinations of glacial sediment and bedrock. And then this is kind of the punchline for the whole thing. I'm sorry, I got to deal with my dog. Hold on. Apologize for that. In a qualitative sense, we have evaluated the general availability of groundwater within the different components, the different layers of these provinces. The addition of this table to this whole groundwater province presentation was a little bit controversial in the early days. We didn't really want to be necessarily sticking our neck out that some areas were really good and some areas are really bad. Just because if you're designated in an area as really good and then you run into groundwater interference problems like problems with cumulative pumping in an area that is perceived as drawing a lake down, then your judgment about that being a good area for groundwater is makes people wonder if it really is a good area. And then conversely, if you're calling an area, if you're pointing out province 5, for instance, is having sort of poor groundwater characteristics, you run into sort of chamber of commerce type issues where people wonder if sort of take offense at that sort of characterization. So our words are very carefully chosen about this. It's all groundwater is local. If you've got your well in province 5 and that's good enough for you, then it's not limited from your point of view, but from a bigger picture point of view, it is. Hope that all made sense. So these are the words that we chose. So looking through this table, you can see that in province 1, for instance, you have 2 moderates and a good, but in province 5, for instance, you've got a moderate and 2 limited. There's very limited bedrock potential in these areas that aren't underlain by Paleozoic bedrock or the Mesoproterozoic Hinckley sandstone. So looking at the bigger picture here, we created some regional cross sections across the state to help visualize some of these, certainly some of the bedrock aspects. And there's a thin layer showing the glacial sediment on top. this package represents the Paleozoic layers, and then this deep darker blue is the Precambrian crystalline bedrock that has limited potential. And you can see from south to north, we've got lots of Paleozoic bedrock here, lots of Paleozoic bedrock here, and then to the north, it's gone. Looking at the west to east cross section, again, we can see that there's these Paleozoic bedrock layers that exist over here are gone over there. The thing that the provinces number 2 and 3 have in common are these thick layers of Paleozoic bedrock. Since the original version was created in 2001, a lot of county atlases have been completed, adding a lot of information for refining some of these major boundaries. For instance, Brown, Nicollet, Sibley, Carver, Wright, a lot of these counties along the boundaries between the 2 and 5 provinces hadn't been evaluated in the County Geologic Atlas program, and now we have information that helps us define that boundary. So I'm going to show you some CGA cross sections showing these boundaries that you'd see at the county level, starting up here in Clay County and then going to Pine County, Redwood County, Nicollet County, and Rice County. And on the cross sections I'm going to show you, they have a different symbology. I apologize for that than the previous ones I just showed you. The glacial till layers of the aquatards are shown in this spectrum of gray colors, the lighter gray indicating sandier till, indicating higher permeability, and the darker grays indicate lower sand content, suggesting lower permeability. So you'll be able to see some of these Wadena till deposits, for instance, with the higher sand content in this first slide. So here we are in Clay County, and the cross-section trace on all these slides is shown with the red line, showing it at a different scale than the cross-section. So the west end is down here, the east end is over here, and then this middle arrow shows the province boundaries. So this is the boundary between 4 and 5. What we're showing here is the edge of the Alexandria moraine. Not a sharp transition. These light tan till layers here represent the Hewitt Formation, again deposited by the Wadena lobe. And when you look in the subsurface, or the surface expression is fairly dramatic based on topography, but in the subsurface it's a little more subtle. You've got presumably thick package of Hewitt till over here, but it doesn't completely disappear. It thins out in the western part of the area. So anyway, kind of an approximate edge of province 4 shown here. Moving over to Pine County on the map. This is a more complicated area in the 2021 version than was shown in the 2000 version. We've got a little complexity with really 4 of the provinces shown here. I'm going to focus in on the transition between province number 1 and province number 3, though, which is shown in this cross section. We're looking at, this area is the subcrop of the Hinckley sandstone, and this orange province is the karst province. So this is where we know there is some karst development in the Hinckley Sandstone, which was a relatively new idea 20 years ago. So it wasn't included in the 2001 map up here in Pine County. So this is a new addition to the province. And if we look down at the cross section, this whole area is the Hinckley Sandstone. And if you look at the overlying glacial sediment, it is in fact less than about 50 feet over this area, which is how we're defining the karst provinces everywhere, less than 50 feet over karst-prone sedimentary rock. And in fact, we know there are sinkholes in this area. This is the Ascoff area in northern Pine County. We don't really know about confirmed sinkholes in the rest of this province. I'll talk a little bit more about that later. This is cross section from the Redwood CGA, going from province 6, which is the Arrowhead and shallow bedrock areas. This is a shallow bedrock area next to this province 5. And the province boundary for this feature is approximately here, where these, to the right of this area, these are all glacial sediment thicker than 50 feet. And most of this area to the left is glacial sediment less than 50 feet. So it's harder to find aquifers when you have less glacial sediment, thin glacial sediment. Nicollet County, this one should be easier to visualize. This again is the border between 2 and 5, where the Paleozoic bedrock pinches out to the west. So this whole package here represents the Paleozoic bedrock, and there's the edge of it right there. And then again, all of this is the overlying glacial sediment, aquifers and aquitards. And then finally, we go to Rice County, showing the border between the number 2 province and the number 3 province. Again, the 3 province is the karst area, and defined as glacial sediments less than 50 feet over karst-prone bedrock. And so you can see this is all glacial sediment here, thins towards the Northfield area, and then east of the Northfield area, the bedrock is covered by only thin glacial sediment and prone to karst. So reviewing some of these changes from 2001 to 2021, we changed some of the province names. Formerly, this province was just called Arrowhead, but we got some comments from people that, well, it's mostly Arrowhead, but there's still all of these little shallow areas down here. So the new name is now Arrowhead, or dash shallow bedrock. To account for that, fairly large change in the edge of the Mount Simon and Hinckley over in this area. The old state map that was available at the time showed really just the subcrop of bedrocks in the area, and they had the Cretaceous bedrock, which is represented by this stippled pattern. I didn't talk about that previously. So the stippled pattern represents the extent of the Cretaceous shale and sandstone. They had it mapped overlying the edge of the Paleozoic bedrock, or the edge of the Mount Simon in this area. We knew that there was Mount Simon past this area, so really this province 2 should have been extended to the west, but because of how they had mapped the Cretaceous and also a kind of a general lack of Mount Simon wells in this area, the old version remained here. The new version has a reevaluated edge of the Mount Simon farther to the west. The Carvins province karst province has changed from the old version, which only existed down here. Now it's not only in the southeastern part of the state, but it's also up in this Pine County, Kennebec area. And then let's see what else. Yeah, the Cretaceous bedrock also got remapped. You can see that it was fairly extensive and laterally continuous in the old version. It's a lot patchier and not as extensive in this newer version. So that was significantly reinterpreted in the new geology. And let's see, I mentioned the shallow bedrock areas. They've changed a bit based on the depth to bedrock map, the current depth to bedrock map. And this is something that will be changing, as the online state map gets updated periodically. So some of these areas could change. And then the colors got changed in the new map versus the old map, mainly because of the detail that was added up in this area. The old color scheme didn't really work as well. There wasn't really the right color contrast. So cartography matters. So getting back to a couple of these main revisions, moving the Mount Simon boundary in the boundary of the province 2 to the west is what I'm trying to show here. These outlying counties are all new CGA counties that have been completed for Part A's and almost all of them Part B's since the original version of the map came out in 2001. So we have the advantage not only of this new CGA work in defining this boundary in through here, but also in 2008 and 2009, DNR drilled a bunch of Mount Simon holes along this edge, which really increased the number of data points that MGS mappers had for defining that boundary. So that was a big help also. And then just to show you what the old situation looked like, here's a cross section from the Mount Simon report showing that Cretaceous overlapping the edge of the Mount Simon. So in the old map, the edge of those provinces was here, and now in the new map, we have a better idea where the edge of this Mount Simon is. So it's over here. The boundary moved to the west. And then the new karst situation in Pine County and Kennebec County was because of this work that was led by Calvin Alexander and Scott Alexander and a graduate student, Bev Shade. They mapped all of these sinkholes in the Hinckley Sandstone. It's this part of Pine County. And then we applied that criteria of less than 50 feet over Hinckley Sandstone to define this whole area. So this is new to the 2021 map. Really, all we know is that the sinkholes exist in this area. We've done a little bit of work recently in the Hinckley area where we think there's a possibility of some sinkholes, but not at the density that was seen up in the Ascoff area. So that's still kind of an open question what the extent of this whole province is up in the Pine County, Kennebec area. So applications. One of the things that you have to live with when you're in the business of making public maps is that you put your map out there and then it gets used, but you don't fully understand how people use it or when they use it or why they use it. They rarely email you back saying, yes, I used this map and it was really, really great. Thank you very much. But there is this thing called the internet. So I can go out on the internet and see and just search for Minnesota groundwater provinces, and I came up with some examples of how it's used. We know since the 2021 version was put online, and I think around March, we've had about 25 hits on the web page. So people are looking at it and apparently using it based on that information. Here's a great application that I found from MinWoo, the Minnesota Well Owners Organization. They've got this interactive province map where you click on these provinces and it takes you to a screen that shows you the groundwater characteristic of those provinces. As you'll see, everyone wants to change the colors of the provinces, and these are nice, happy, cheerful colors. So this is maybe one of the better applications I've seen. Here's sort of a challenging use of the information, and I guess I could even call it bad cartography since I did it. This is it's a very busy map. The intention is to show these areas of concern as the DNR defined them on a map, and then to add some of these province elements to the map to explain why, some of the challenges in these areas. Once you get into it and start using it, maybe the unfortunate cartography goes away, but not my favorite presentation. Here is a version of the map that's on the PCA website. And oh, by the way, there was a very early version of something like the province map that showed up in an obscure DNR publication in 1962. And at that time, this is how the provinces were defined, with fewer provinces. There was no differentiation in this area. The whole idea of karst was kind of left out. So if you're using this map from a purely sort of water quantity point of view, this works because this whole green area has pretty good groundwater quantity characteristics, but again, it leaves out the karst issue, which is an important water quality thought issue. And so this could be updated to include the 2021 map with the karst designation in it. Here's something I saw from, I believe, maybe postdoc students from the Water Resources Center. They did a chloride study where they used the province map as a backdrop for higher chloride areas versus lower chloride areas. This is a use of the province map by the U.S. Geological Survey. This is a relatively recent publication. I haven't read it yet, but they compared the watershed, the Cannon River watershed with the St. Louis River watershed, and then presented them the outlines of the watersheds on top of the province map. I think probably leading up to the reason why the characteristics of these rivers in the two areas are probably very different because of groundwater, a lot of groundwater contribution probably here and not so much up here. These are maps made by the DNR using, again, the province map as a backdrop, showing comparing water levels in observation wells over time. Here's a 9-year period showing where levels have gone up versus where they're going down. I think and then again, everyone has to change the colors. There's this set of colors, and then one year they used this set of colors. What I got more out of this map maybe than I did this map, because I see that the observation water level trends were going down. The black dot is down in this western province, making me think that if the water levels are going down in a province with limited groundwater availability, that should be a red flag. So that's maybe a good use. Here's another example used by the Minnesota Sustainable Housing Initiative, and they had to change the colors. And they're very subtly suggesting by bolding the word good that this is where you want your house, I guess. Although they didn't say that outright. This is a use by an organization called Clean Up the River Environment, CURE, and their webpage was entitled Groundwater 101, Why Should I Care? So we're getting close to the end of the hour. Happy 20th, Minnesota Groundwater Provinces. And these are some of the invaluable resources that I use to do this map update. I want to especially mention these online statewide maps that the MGS has put out. They're super useful, easy to use. This official geology map, the bedrock topography map, and the layered bedrock geology map. Really an invaluable resource for doing a map like this. And any questions?
Thanks, Jim. So if people do have comments, type them into the chat, and we can throw them at Jim and see if we can stump him a little bit. We do have a few comments in the chat. Apparently, Jim, it is your birthday, so happy birthday.
Oh, yeah, thanks.
People are saying happy birthday. So
wow.
happy birthday to you.
Happy birthday to the map and happy birthday to me.
And while people are thinking a little bit about what they might want to ask, I'm going to ask a very untutored question that I think you made reference to a little bit at the end there. It seems to me like that the groundwater provinces do correspond, at least roughly, with what I've seen of the ecoregions that I've seen in, overlain on Minnesota maps, in particular with surface water, ecoregions. Do you want to pick that up and run with it a little bit? And maybe it's kind of a given that those things do correlate. But it seems to me the more I'm seeing of groundwater provinces, ecoregions, and what you mentioned about stream regions, that we're trending more and more toward this kind of grand unification theory of things water. And maybe you want to comment on that a little bit.
Right. I'm familiar with the ecoregions. There's sort of a band in western Minnesota and southwestern Minnesota, which is kind of the prairie area, and then there's a mixed forest area in the middle, and then the arrowhead is more conifers. I think that's how it breaks down. I think a lot of that is, some of it relates to the provinces. Certainly, it's hard for my, I'm not much of a tree guy, but hard to grow. It's a combination of geology and climate that puts the conifers up in the arrowhead. So to a certain extent, the geology matches there. I think the coincidence between the mixed tree zone and the prairie zone is more climate driven though, and it's just kind of a coincidence that the boundary is sort of approximately matches in there. I think there's something there in what I said. There's probably a lot more to it for people who know vegetation better than me.
Dan asks in our chat box, the maps and cross sections are fantastic. Are they available?
The map and with the big cross sections are available. They're on the web page. And certainly the little cross sections from the county geologic atlases are available from the individual atlas web pages. So yes, it's all available. If I'm catching the question right.
what it sounds like. Without further clarification from Dan, I'm kind of assuming that's what he's asking. Paul gives a shout out. We find that many educational institutions at all levels use this document a lot to help explain Minnesota groundwater. Very helpful. Yeah, I tend to agree. These are great maps that, as you mentioned, Jim, just really seem to have wide applicability, everything from sustainable housing to, predicting or at least giving some insight into water levels across the state.
Yeah, I was so happy to see that it's really seems to have worked its way into the general knowledge base that we have for natural resources in the state.
Suzanne asks, has DNR done anything to publicize the map update, such as a press release? Otherwise, web searches are likely to turn up the quote unquote old map, and people will continue
the old
to
map is
use
no
it.
longer out there. It's been replaced by the new map, and we rely heavily on Gov delivery. So we have this list of hundreds of entities that we send this information to, and apparently it gets pretty wide viewing based on these Gov delivery releases that we make, and then they're sort of traditional press releases too that DNR does. Pretty sure that was part of one.
Gene Coleman asked, are there maps with public water systems overlaid on these provinces available anywhere? That's a good question.
Not that I know of, although I wouldn't be surprised if that's been done. But I've never seen such a thing.
That's an interesting thought.
I began the talk with two interstate rural water system projects, and if you overlaid those in addition to the more local rural water projects, I think you would find most or all of them in that western province, because that's where they can't rely on individual wells as much as they can in other provinces.
And Gene asks, also, what is the future of the CGA efforts in other counties?
Oh, well, let me find that map. The Part A, this is close to being the most current, if not the current, Part A planning. So all of these green areas are counties that are in progress at some point. And then the purple indicates previous Part A atlases that are going to be updated. So Ramsey and Dakota County, for instance, have some fairly old, only Part A atlases, and so once the new updated A's are done, then we'll be doing a B as well. I think these are actually Rock and Novas. I think that the A's are actually done and published. We are currently collecting data from these two counties. So we've got these two in progress. Let's see, I can go over to the Part B atlas too. Hennepin is currently in review. I was the author on that. I'm working on Isanti now. Candy Ojai is also, I'm working on, let's see, Winona is actually, it's not completely done. And out there published, it's very nearly done. All of these, all these are in progress. Cass is in their internal review right now. And these three are in progress as well. So a lot going on.
Well, having referred to the county geologic atlases in the past, I just find them really incredible pieces of work and really helpful in trying to get further insight. I remember I was using them back in the day when I was doing remediation work, and they were really helpful in kind of doing some kind of ground truth thing to what we were seeing at different sites and the vulnerability of groundwater to contamination. So yeah, those are really great.
Well, and that's great to hear. And I had the same experience when I was in consulting. There weren't that many in those days, but if I got a remedial investigation project in a county, the first thing I would do would be to see if there's an atlas, and then you would have a general sense of what to do at that point. And in the absence of that, really all you had was a topo map and something at a state scale that wasn't that terribly helpful sometimes for a local problem.
So are these kind of resources or efforts and mapping been done a lot in other states, or is Minnesota kind of rich in this information?
There are things like this in other states, but I think our combination of detail and collecting samples and all that is somewhat unique in the country. And even just having a central database of well log information is an enormous step that a lot of steps have not taken. And that's really kind of the underlying data that controls so much of these things. Just having that stuff centralized and digitized and searchable is a big deal.
Yeah, I believe it's Jane again. She says, I'm sure MDH would be quite interested in creating the public water system map if it doesn't yet exist. More work yet to do.
Right,
Glad
and
that added to our chat. Yeah.
right, and we're sort of wondering if this update that I'm talking about today will ever be updated again. And
Hmm.
I think it probably will. I think maybe the update I made was kind of a big jump ahead. Maybe subsequent updates will be more incremental as we get all these boundaries figured out around the state.
Yeah, that was actually my final question, unless other people have things that they would ask. In addition, I was kind of wondering, are these kind of periodic updates, or are there more updates in the works, or I didn't know how frequent these kind of updates were. But it
Right.
sounds like this might be kind of last hurrah for a while.
Well, maybe. I don't know that we ever really had a plan for this. Um, the future for these sorts of maps is to have an online version that's continuously updated, and
Hmm.
MGS has gone a long way in that direction, and we're considering the same thing. But that's probably the next logical step, is to do something like that. And then you don't have this static rollout, one-time rollout, and then you have to wait 10 years for the next one. Things change continuously as things, at least ideally,
Hmm.
things are changed continuously as more things are learned.
It just seems to be such an incredibly good resource. I would think that there would be continued interest in funding that kind of work,
Well, yeah,
as
and
long
then
as we were able to.
yeah, in the world of funding, this is has no dedicated funding. Never really did. It was, um, which was kind of one of the wonderful things about it, having almost completed a career where I've had lots of
Hmm.
projects with big budgets and multiple partners and lots of meetings and that sort of thing. This one was kind of nice in that it was fairly simple and straightforward, and used a limited team of people. Not that there's anything bad about the bigger projects, but sometimes the small ones are nice too.
Hmm. Well, I don't know if anyone else has more questions for Jim that they'd like to ask. We're kind of closing in on 10 o'clock. Jim, unless we do see a few more questions, thanks so much for agreeing to give this presentation. I learned a ton. And it's one of the nice things about pulling these seminars together is it's like a continual education on
Yeah,
things.
well, and
And
then
this has been one of them. This has been great.
thanks. Yeah, and then for people like me, it's nice to have an excuse to think through some of the details of the report and its implications.
Well, hey, great. I don't see any more questions popping up. So maybe what we'll do is close this one up and thank Jim again for presenting and once again wish you a happy birthday out
Yeah,
there.
thanks very much.
All right. Thanks much, Jim.
Bye.
Yeah. Bye-bye.